Hi guys, and welcome to section 4 and section 5 of chapter 9 of the pre-algebra program. Section 4 has one theorem that I would like to talk about, but it wasn't worth doing an entire video for, so I thought I would just slide it into our 9-5 video. And the rest of section 4 has to do with classifying triangles similarly to what we were doing in section 3. So you'll have a little bit more review of that in section 4, plus one additional theorem. And then in 9-5, we're going to talk about something called the Pythagorean theorem. So I'm just going to loop it all together, but when you sit down to do section 4, feel free to only watch just the first few minutes of this video to get this theorem down, and you'll be able to do your assignment. Then refer back to the video when you do section 5. Okay, so section 4 has something called the triangle angle theorem. And what that means is that all of the angles of a triangle, let's call them X, Y, and Z, every time those three angles have to add to 180 degrees. You might have heard that before, but now we're kind of officially declaring it as a theorem, and it's true every single time. So when you're looking at the angles inside the triangle, we know that it's a triangle if all of those angles add to 180. And it also allows us to find missing angles, and that's primarily how we're going to use it in this section. So, for example, if I have a triangle and it has a 90-degree angle and I have an angle that's 30 degrees, I could find a missing angle because I know that all three of these angles have to add to 180. So I could write it out something like this. My 90-degree angle, of course, is worth 90, plus the 30-degree angle, plus the missing angle, together all has to add to 180. And now this should look very familiar to you. This is going to be one of the reasons you'll see why we hit so hard in the first semester solving 1- and 2-step equations and being able to gather like terms, because then we can utilize those skills in really fun ways like solving triangles. So now you're going to combine your like terms, and you're going to solve this for x, which at this point you should feel really good about. And so my missing angle here is 60 degrees, since all three of those angles have to add to 180. Okay, let's do another one. What if I have a triangle such that this is 70 and this is 40? Okay, that's not exactly drawn to scale, but that's actually good practice for you too, that not every angle is going to look exactly what its measure is. I know that all of these angles together have to add to 180. So I'm going to write them down just like that. 70 plus 40 plus x equals 180. Again, I'm going to combine like terms and solve for x. I'm going to subtract 110 from both sides, and x is going to give me 70. So that's my missing angle. Okay, I'm going to do just one more like this for you. I swear to you, it's really just this simple. Hopefully you're feeling that way. Wow, okay, I just lost my triangle. All right, let's do 52 and x and 30. Again, I know that 52 plus 30 plus x all has to add to 180 degrees. So 52 and 30 is going to give me 82 plus x equals 180. And then if I subtract 82 from both sides, hopefully this is old school for you. You're going to be feeling very good about solving for x here. Then my missing angle measure is going to be 98. Okay, at this point you can pause the video and do your section 4 homework. I would just review the section and finish up the notes. reviewing those classification of triangles because that's the second part of the section. And that is really important because we need to be able to identify our right triangles in order to move into section 5. Okay, you guys, let's do 9-5. 9-5 is a super fun section. In here, we're going to learn something called the Pythagorean theorem. Maybe you've heard it before, maybe you've seen it a little bit, but now we're really going to kind of dive into it and get our hands dirty. It's super useful, and I promise you this is a skill you're going to be using literally every single year of your math career into some of the most some of the highest forms of mathematics you can do. I use it with my calculus students. So this is a very fundamental skill. We're going to stay here for a couple of days and just get lots of practice at it and make sure that you're comfortable how to use it and being able to find it. And actually, I think it's a little bit fun, so hopefully you guys won't mind it too much. Okay. And if you've seen the Lego Batman movie, you've actually heard Robin do this little jingle. If you haven't seen the Lego Batman movie, you should because it's hilarious. And at one point, Robin is testing his knowledge and he's doing a little jingle and he's saying a squared plus b squared equals c squared. And I always get a real kick out of that when I watch that movie. So when you get done with your homework tonight, go watch Lego Batman. All right, so what does this mean? We have all of these letters and this new kind of symbolism with the 2's, and it might be a little bit weird, but I promise it's not so bad. Okay, Pythagorean theorem is a theorem that was identified and written clearly out by a guy named Pythagoras. And what Pythagoras said was in any right triangle. So this has to be true only for right triangles. So we're always going to be looking for that right angle symbol in our triangles to use Pythagorean theorem. That the square, that's what this means, of the 2 sides added together equals the square of the longest side. So C is our longest side. Hopefully you know that that's called the hypotenuse. If you don't, you're learning it today. The other 2 sides are called legs. And he said that if you take the number of a leg times itself plus the other leg times itself, then you're going to get the square of the hypotenuse. Okay, so let me show you what I mean by that. Let's say we have a right triangle and the sides are 3, 4, and 5. All right, if you're not familiar with the squared term, in this case, we can let either one of these numbers be A or B, but our longest side always has to be C. So our hypotenuse is always C. And if for some reason you have a hard time identifying that in the triangle, know this, that the hypotenuse is always opposite the right angle. So all you have to do is find the right angle, and the side opposite that is going to give you the hypotenuse. Okay, so then if we take 3, oh my goodness, squared, and we add 4 squared, we're going to get 5 squared. Now we did talk a little bit about exponents before, but just to review, remember that that squared term means that we have 2 of them. So it means it's 3 times 3 plus 4 times 4, and that equals 5 times 5. That's what that square is. And we are going to use our calculator for this section again. So we're not going to be dealing with all perfect squares. And there is a little square button on your calculator. If you are unfamiliar with it or need help identifying it, ask a parent or a sibling or shoot me a text and I can help you identify that button, and that can help if the numbers get a little bit big. But for my notes purposes, I'm going to try to keep things relatively small and easy to use. It's just for clarity. Okay, so 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And then sure enough, 9 plus 16 is 25, and 25 equals 25. Okay, so this is a classic case of what we call the Pythagorean theorem. It's really nice because all of the sides are integers, so that makes them really easy to work with. But Pythagoras taught us that this side ratio holds every time in a right triangle. And so it makes it handy to be able to identify side values. In 9.4, we were working with angle values, and we were able to use a theorem that told us that all of the angles add to 180, so we could identify missing angles. Pythagoras is teaching us that we can identify missing sides. So again, this ties back with what we were learning with the side and angle classifications in section 3 and 4. And so we can identify and find values either via angles or via sides. So that's super handy, actually. All right, so let's break it down. Let's do some more. All right, what if we have a triangle, always a right triangle, and the side lengths are 5, 12, and C. Now, in this book, the legs are always written as A and B. The hypotenuse is always written as C. So when you see and identify the letter, you will know which piece of the theorem you're looking for. So C, of course, is always the hypotenuse, and that goes at the end. So our theorem, again, I'll just write it. I'll probably write it several times as we go here, is a squared plus b squared equals c squared. So for us, we're looking for this value. All right, when it comes to our legs, we can appoint either one as A or B. I would say typically we usually assign the smaller number as A and the larger number as B, but we learned in one of the sections that addition is what's called commutative, which means order doesn't matter. So you don't need to be hung up on trying to identify which one's A and which one's B, because the order of addition doesn't matter. So you're going to be fine. But I will say, for my purposes, in the notes and things like that, you will see that the smaller number will be written as A and the larger will be written as B. Okay, now we're just going to plug these values in. So B was 12, and I'm looking for C. So 5 squared, remember that's 5 times 5. This is going to be 12 times 12. So that's 25 plus 144, and that equals C squared. Together, that's going to give me 169 C squared. Okay, and now, folks, we bring in what we just learned earlier in the chapter with our square roots. Remember, we introduced this form of finding the value C, and other letters too, in section 2. And remember, I said that we needed to take the square root of both sides in order to be able to find C. And I was trying to get you a little bit used to this notation, knowing that we were going to have to use it here in section 5. So for some of these that are perfect squares, you might be able to identify this as 13. But I'm guessing a lot of you will need your calculator, and you'll need to put in the square root of 69 here in order to be able to identify that C is 13. So our missing side length is 13. Again, if you're having any trouble with that calculator portion, please reach out from assistance. I would say probably most people have done squares and square roots on the calculator, adults I should say, so they should be able to assist you, but please reach out if you're having some confusion. But go ahead and run your calculator with the notes to make sure that you're getting the values that I'm getting, and just to familiarize yourself with that. Okay, let's do another example. Again, we're always going to be in a right triangle. What if we had side lengths of 2 and 3, and again, trying to find C? So A squared plus B squared equals C squared. A, for my purpose, I'm going to identify as 2. That's my small one. And then B is 3. And of course, I'm trying to find C. 2 squared is 4. Remember, it's 2 times 2. 3 squared is 9. And that's going to equal C squared. And now 13 equals C squared. Now be careful, folks. A lot of students will forget at this point that we have c squared here and we need to solve for c. They see this nice integer 13 and they think that they're done, but you're not. We must now take the square root of 13 in order to be able to get c. Now 13 is not a perfect square. You're going to have to type this into the calculator. And again, in general, right now we're just rounding to the nearest tenth. So you should get c equals 3.6. All right. If I'm going too fast, you guys, make sure that you're pausing the video and catching up. I'm going to try to get through 2 more examples here for you, just so that you have a lot to look at and a lot to review. I'd rather do a few too many than not enough for you. All right. What if we had a triangle with side lengths 7, hypotenuse 10, and missing side B? Okay, so now I'm not finding C, now I'm finding B. All right, which means 7 has to be my A. Now they're giving me my hypotenuse, so now we got to be really careful where we place our numbers. So A here is 7. But I'm looking for B, so I'm going to leave that in there. And now my C is 10. Okay, but now we're going to solve similarly as we did before. 7 squared is 49 plus B squared, and 10 squared is 100. All right, well now I need to solve this for B squared by subtracting 49 from both sides. And now B squared equals 51. Again, don't stop here. We have to take the square root. We have to take the square root of both sides in order to be able to get B. And so if you take the square root of 51, you should get 7.1. All right. Let's do one more here. Sorry, my video is running a little bit long, but I wanted to make sure we got all this in. All right, this time I'm going to solve for A. So I have A squared plus B squared equals C squared. A I don't know, so I got to leave him. B, of course, is going to be my other leg. 12 is my hypotenuse, which is C. So this is going to be 4 squared, and that equals C squared. All right, A squared equals 16, or excuse me, A squared plus 16 equals 144. And then if I subtract 16 from both sides, you get A squared equals 128. Now don't forget to take the square root of both sides. And then A should equal something like 11.3. It's our missing side. Okay, like I said, we're going to spend several days here. You're going to get lots of review. Hopefully it'll start to feel a little bit more comfortable as you get used to it. Make sure that you're asking questions, finishing up your notes, read through the section, and begin your assignment.